Hello. Today, we are going to talk about the chemical reaction in coffee roasting. Raw coffee beans are like a warehouse full of chemicals. At present, scientists have identified more than 2,000 known ingredients. Among them, 700 to 850 substances belong to aromatic components, which can be called the most complex aroma in human diet. We all know that there are many chemicals in raw beans, and these chemicals undergo chemical reactions in baking. It develops the flavor that we taste in the cup. Let's count these chemical reactions together. Maillard reaction. Maillard is a very common chemical reaction in our daily life. For example, bread, grilled fish, bacon, tea, soy sauce, soy milk, and other condiments have Maillard reaction. The Maillard reaction is caused by the interaction and decomposition of monosaccharides and amino acids under heating, non-Meissen combination reaction. New flavors and unique aroma compounds are formed for the coffee beans, while the Maillard reaction also produces melanoids, which give the coffee a tan color. Usually the Maillard reaction produces aromas of nuts, caramel, malt, etc. The Zwick degradation reaction is a reaction process dependent on the Maillard reaction. It allows amino acids to react with trigger chemical reactions. Molecules grouped in sugar groups to produce compounds such as aldehydes and ketone. Compound is essential. Caramelization reaction. The Maillard reaction comes to an end. The caramelization reaction begins. At about 170 degrees, the heat causes a lot of complex carbohydrates to break down into smaller sugar molecules that can be dissolved in water. This means increasing the level of sweetness and the resulting coffee. This reaction continues until the end of the roast, contributing to the sweetness of the coffee's aroma. With caramel and almond flavors, the caramelization reaction further browns the coffee beans, producing new aroma substances. It degrades the residual trace sugar in beans and improves the bitter and sweet quality of coffee. Many volatile and non-volatile chemicals are also produced during coffee roasting. Volatile compounds are organic chemicals that have a high vapor pressure at room temperature. Many of these are formed in the Zwick degradation reaction. In the developmental stages of torrefaction, when the aroma and volatile compounds of the product are released, we will feel this unique coffee odor. Caramel flavor contribute by halothane compounds include aldehydes to increase fruity, greenery, aroma. Carbon dioxide is a volatile compound. It will not affect the aroma, but it will affect the mellow thickness of coffee. Many non-volatile compounds contribute to the flavor and flavor characteristics of coffee, such as caffeine, which is responsible for some of the bitterness. Caffeine is naturally present in coffee and remains constant during roasting. Other non-volatile compounds provide sweetness to the sugars and mellowness to the paper. Melanins, which can change the color and alcohol thickness of coffee beans, are also non-volatile compounds. Sulfur action refers to the complete carbonization of solid or organic matter quarantine air by dry burning. designed to prevent oxygen from supporting combustion or explosion. Carry out dry sulfur misconduct penalty by wrapping wood chip in tinfoil paper. It can be used to make charcoal and produce coke products such as formaldehyde, acetic acid, and tar. Although coffee roasting is carried out in semi-enclosed drums or metal tanks, oxygen can still enter and exit, unlike the oxygen-free smoldering environment of the mainstream. However, under normal roasting conditions, it is impossible for coffee beans to be roasted to complete carbonization and combustion. Therefore, the dehydration, pyrolysis, dehydrogenation, and charring that dark roasted coffee beans go through before they come out of the pot are comparable to those of sulfite. Moreover, roasted beans will also produce a lot of burnt and fishy odors. Therefore, in dark roasting, the development of intense aromatic compounds is largely due to dry distillation. Cellulose is the source of sulfur aroma mercaptan. Cellulose. Recently, scientists have found that the rich aroma of medium dark and dark roast coffee, the caramelization of sucrose. It is the polysaccharide cellulose that comes from the thick cell wall structure of raw beans, which is the hotbed of thiol compounds. Thiol compounds are the main source of the aroma of ripened coffee. Mercaptans have been built since two Nobel laureates, Rachstein and Staudinger, reported in 1962 that the mercaptan alkane GP group dione was built. After the important role of coffee aroma, scientists have actually made significant progress in this area over the years. Many studies have reported that the attractive aroma of coffee, whether light roast, medium roast, or deep roast, is mainly due to thiol compounds, aromatic compounds derived from mercaptan ethers, ethanol ketones, or aldehydes. According to the study of coffee aroma chemistry, the precursors of thiol compounds are arabinogalactan and cysteine. So, cellulose is stored in the thick cell walls of coffee bean, in lignin, and one of that raw material for synthesizing the thiol compound, cyanaldehyde, is a degradation product of arabinogalactan, while the second source of sulfur for the thiol compound comes from the product of the pyrolysis of cysteine. In other words, the thiol compound is an aromatic product of the degradation of the cellulose lignin and amino acids of the cell wall of the coffee bean for polymerization. To put it bluntly, it is the enzyme sodium reaction between sugars and amino acids. Mercaptan compounds can be said to be polymers of aldehydes and ketones with sulfur. Most people think of sulfur when they see the word sulfur and the taste of rotten eggs. However, the combination of thioethane and aldehydes and ketones will create the aroma of raw coffee. Sulfides in food published by the American Chemical Society show that the process increases with the degree of roasting of coffee. According to the readings from the meteorological tester, the retention of very shallow coffee is less than 10,000 units, and the retention of moderate coffee has increased to 50,000 units. The retained elevation of the depth is up to 70,000 units. In the laboratory, both carbohydrate and high energy to produce this process in mid-tone baking. The above content is much higher than that of the former shellfish, which coincides with each other, indicating that the production of mercaptans requires higher energy. The Olate has chocolate, cream, sugar, cocoa, banana, egg, and even meat aromas, which are the source of light to deep coffee aromas. There are also three compounds associated with coffee aroma, including tetraethyl precreosote, alkane GP0, and the heteroalkylylthiol, which in turn are associated with coffee's thick cell walls. Coffee beans contain 40% of the seed cellulose, which makes the cell wall structure of coffee much harder and thicker than other seeds. Although the above research report indicates that the retention increases with the degree of roasting, please do not misinterpret that the more roasted the coffee is, the more mellow it is. Know that baking is an extremely complex degradation polymerization reaction of thousands of compounds. Mercaptans increase with increasing degree of baking. However, the accumulation of carbonized coke particles and the degradation products of chloropicrin by deep roasting also increased rapidly. It is easy to hide or offset the remaining fragrance. After the dry distillation, let's talk about the pyrolysis reaction that bakers often talk about. Pyrolysis. What is pyrolysis? At what stage does coffee experience this reaction? Remember that the pyrolysis reaction exists only in the coffee roast. Thermal cracking, also known as pyrolysis. Thermal cracking and high-temperature cracking refers to the high-temperature decomposition of organic matter and inert gases. This reaction involves simultaneous changes in chemical composition and physical phase state, and the thermal cracking process is also known as devolatilization or volatile stripping, commonly abbreviated as devol. Pyrolysis and dry distillation. Similar to the cracking reaction of liver tumor and environment, which belongs to thermal decomposition reaction. However, because of the differences between the cell part and their specialized uses, they are called by different names, such as retort destruction, distillation, and cracking reaction. If the temperature of the pyrolysis is further increased, a carbonization reaction occurs, and all the reactions are converted into carbon as such. The pyrolysis reaction generally occurs during the coffee roasting state. High-temperature pyrolysis reaction, the high-temperature pyrolysis reaction of organic matter in the absence of oxygen. The reaction temperature is 200 to 300 degrees, and the final form is similar to coke. Reaction of burning charcoal in charcoal kiln. In the baking process, on the one hand, it will produce highly volatile, small molecular aromatic substances. On the other hand, it will convert the dark taste produced in the enzyme sodium reaction, and it will help coffee to add flavor and remove bitterness. But if you don't master it well, it will turn into charcoal coffee. In addition, the change of acidity in the process of coffee roasting has a great influence on the final flavor of coffee bean. Baking degrades some of the acids and produces others. For example, citric acid and tartaric acid, which produce fruity and sweet flavors, are broken down during baking. Therefore, baking for a long time or at too high a temperature can substantially reduce the sweetness in the final baking profile. Coffee contains a large amount of chlorogenic acid, which can be decomposed into caffeic acid, quinic acid, and chloric acid after roasting. Quinic acid is believed to be responsible for that bitterness and astringency produced by coffee. Science has not yet fully understood the chemical reactions in coffee roasting. How to roast the ideal coffee according to the characteristics of coffee penetration. Baking needs the combination of science and experience. I hope that students will be brave enough to spend the spirit of exploration in their future study and combine it with practice. Discover the scientific secrets of coffee roasting chemistry and add to the science of chemistry and coffee. That's all for this lesson. Thank you.